Chapter 4, Lesson 2 is about ionic bonds. And so yesterday we talked about what an ion is. And so an ion, if I scroll down, an ion is anything with an electrical charge, okay? An atom or an element with an electrical charge. And so an atom gets an electrical charge if it is to lose or gain electrons. So that's what an ion is. It's an atom with an electrical charge, and it only has an electrical charge if it loses or gains electrons, okay? Polyatomic ions, again, are ions, just more than one. So an example over here, bicarbonate, HCO3. That is 3 elements, so that's more than one, so that's what we call a polyatomic ion. Then we said when you have ions come together, they form these brand new things, and they are called ionic compounds. Okay? So like we said before, how do you form an ion? Let me scroll down a little more. It's an atom, sorry, reverse that. An ion is when you lose an electron. Typically the metals like to do this. And if you lose electrons, you actually become more positive because electrons are negative. And if you lose negatives, you actually become more positive. The reverse is true for nonmetals. Nonmetals like to gain electrons. So nonmetals like to gain electrons. And if you gain negative things, gain electrons, you become more negative. And so here's how it really works. Okay, sodium will transfer an electron. It will give up an electron over here to chlorine. And so when chlorine gets that electron, it now has a full shell. So right down here you see the kind of example. It now has a total of 8. And then sodium also will then have 8 once it gives this up because it goes down to the shell below it. And so what happens is you have this bond that happens between these two ions, and we call this new thing an ionic compound. Okay, so that's a bit of a review from yesterday. What we're going to be doing today is we're going to be learning how to write ionic compound formulas, or chemical formulas for ionic compounds. So a chemical formula are these examples right here. H2O, that is a chemical formula. MgCl2, that is a chemical formula. CaCO3, that's a chemical formula. Now the little numbers you're seeing here, this little 2, that's called a subscript. Subscript is a little number that tells us the ratio of the elements. So what it means is that there are 2 hydrogen for every 1 oxygen. There is 1 magnesium for every 2 chlorine. So we look at this example over here at calcium. We have 1 calcium, 1 carbon, and we have 3 oxygen. Okay? All right, so let's work on making these chemical formulas. So go ahead and write this rule down. There's really 2 rules there. There's really 2 sentences there. To write a chemical formula, first you must write the symbol of the positive ion, and then write the symbol of the negative ion. So if you look here, magnesium chloride. Magnesium is positive, chlorine or chloride is negative. So you're probably asking, how did I know that? Well, here's where your periodic table comes in. So I'm going to pull out my periodic table. This is the one that Mrs. Hill hopefully gave you. Hold on, let me stop just for 1 second. Okay, I make my screen a little bigger. Here we go. So if you look over here on the left-hand side, you're going to notice at the very, very top, these are all positive numbers. So hydrogen, lithium, sodium, potassium, they all will have a positive 1 charge when they become an ion. Reason is these guys only want to get rid of 1 electron. And if you get rid of 1 electron, you have a positive charge. Same thing's true next door. Beryllium, magnesium, calcium, these all have a positive 2 charge because they want to get rid of 2 electrons. Over here we have boron. It wants to get rid of 3, and so it has a positive 3 charge. Once you get to carbon, silicon, this is where it comes to the unique. Carbon can either gain or it can lose 4 electrons. So it can either gain 4 or lose 4, kind of in the middle. It depends on who it's doing business with. Finally, on the right-hand side, you have all your negative ones. Nitrogen, phosphorus, they want to gain 3 electrons. Oxygen, sulfur want to gain 2 electrons. Fluorine, chlorine, bromine, they all want to gain 1 electron. Okay, so that's where I'm getting my positives and negatives from. So if I were to kind of draw that for you, pretty much the left-hand side here, These are all my positive things. On the right-hand side, these are all my negative things. Okay? So let's go back to our notes. Magnesium is positive, chlorine is positive. So first step, it says write down the symbol. So let's write down the symbol for magnesium. It is Mg. And chlorine, if you look at your periodic table, chlorine or chloride is Cl. So we just did step 1. We wrote down the symbols for the positive and the negative ions. Next it says add subscripts if they are needed to balance the charges. So let's look at the charges on our periodic table. Here we have magnesium. Magnesium has a positive 2 charge once it becomes an ion. If you look over here, chlorine. Chlorine has a negative 1 charge when it becomes an ion. So let's write those positive and that negative number down right above our numbers. So let's just write a different color. This is going to have a 2 plus charge, and chlorine is going to have a 1 minus charge. So if we were to do some subtraction, if we did 2 minus 1, the answer would be a positive 1. This is considered not balanced. We really want our number to be the number 0. Okay? So to get this to be the number 0, what it means is that this number, this 1 minus, actually needs to be a 2 minus. And to make this into a 2 minus, that would mean we would need 2 chlorine. So we're going to write the subscript 2 there to give us 2 more chlorine. So 2 times 1 is 2. 2 minus 2 is 0. And that's your answer. MgCl2, that is the chemical formula for magnesium chloride. Okay, let's try another one, see if we can't figure this out better. Lithium oxide. Lithium oxide. So let's go to our periodic table, lithium. So here we have lithium right, let me get a different color for this one. Lithium's right here, Li. It's going to have a positive 1 charge. And then the other side is oxide. Sounds a lot like oxygen, that's what it is. So oxygen's right here is a 2 minus charge. So we're going to write that on our paper. Li is positive 1, and then oxygen negative 2. So Li and O for oxygen. Like we said, Li has a positive 1 charge, and oxygen has a 2 negative charge. Are these going to balance? The answer is no. So what we need to do is we need another lithium. So if I had 2 lithium, 2 times 1 is 2. So we'll change now into a 2. 2 minus 2 is 0, and so this is considered balanced. Li2O. That is the chemical formula for lithium oxide. Okay, so let's just try one on your paper. So let's go to your paper here, number 6. Let me get a marker here. So potassium. Potassium is a letter K. Its charge is a positive 1. Iodide is the capital letter I. Its charge is a 1 minus. These are actually already balanced, so that is your final answer, K and a capital letter I. Go ahead and stop this video and do the next two, number 7 and number 8. Alright, magnesium is Mg. It is a 2 plus. Oxygen is O. It's a 2 minus. And that's balanced. We're done. Aluminum, Al. It has a 3 plus charge. And chlorine, Cl, has a 1 minus charge. Uh-oh. We're not going to be balanced, so we need to make another, 3 more chlorine. So I'm going to do a little 3 here. So change this into a 3. And now we are all balanced. Alright, now I need to show you what happens if we have polyatomic ions. So let me kind of go back to this. Do not copy this in your notes. Let me just scroll down for a second. Okay. Hopefully you've been noticing if there's an ending of I, the last second word always is a little bit different. If it ends in IDE, this is talking about a single element. you will use your periodic table if it ever ends in IDE. Okay, so like oxide stands for oxygen, so use your periodic table. If, on the other hand, it ends in ate or if it ends in ite, so example, potassium nitrate or potassium nitrite, these are examples of polyatomic ions. So instead of making you memorize this, on the back of your periodic table, you should have a sheet that looks something like this. These are all examples of polyatomic ions. Okay, so if you kind of look, phosphate, phosphite, phosphate, phosphate, sulfate, sulfite, they all will end in ate or ite. Now I can't say that's true for all of them. There are a few exceptions, and you're more than welcome to circle these, and that's what I would do if I were you. Azide, right here, ends in IDE, as well as cyanide, hydroxide and peroxide, and finally, oops, go back up, and finally ammonium and hydronium at the very, very bottom. Other than those 6 right there, all of them will end in ate or ite. Also, something I want to draw your attention to is that all of these guys will have a negative charge except for these 2 at the bottom. Ammonium and hydronium. They are the only 2 that have a positive charge. All the rest are negative. So, let's try an example together in your notes. I'm going to go back up here. And let's try doing potassium nitrate. Potassium is the letter K. It will have a 1 plus charge. And then we have nitrate, ATE. So that tells me I need to go to my polyatomic table. And let me erase this really fast so I can get this out of the way. Hold on. All right, let's erase that. Gone. All right. Nitrate is right here. Nitrate. Nitrate is NO3. And you're going to notice it says the little minus sign. That symbolizes that this has a -1 charge. So let's go back to our table. Okay, so here we are, and now we have NO3, like we said, and we said it had a 1 minus charge, and this is actually balanced. This one's already done for us. KNO3 is the chemical formula for potassium nitrate. Let's try another one. Sodium carbonate. Sodium is Na. It has a 1 plus charge. Carbonate, ATE, well, that tells me I need to use my little sheet again. So if I'm going to go over here to carbonate, it's down here at the bottom. Use a different color. Carbonate is right here, CO3. So CO3 with a 2 minus charge. So let's go back and let's write that in. CO3 with a 2 minus charge. Okay, so that tells me I need to balance this out. I need actually to have a 2 over here, so I'm going to put a little 2 as a subscript for my sodium. That'll change into a +2, and now we're balanced. Na2CO3 is the chemical formula for sodium carbonate. So here's my last example. This is kind of the hard, tricky one. Magnesium bicarbonate. So first, let's write the symbol Mg. That stands for magnesium. It is a 2 plus. And bicarbonate, that tells me I need to do my list again. So let's go back to my list. Bicarbonate, it's a different color. And bicarbonate's right below carbonate, obviously, is HCO3. HCO3. And it has a -1 charge. Let's put that in. HCO3. CO3. And has a 1 minus charge. So we actually need more bicarbonate. So to do that, what you do is you put parentheses around the whole entire polyatomic ion, and you put a subscript of how many you need. So we actually need 2 more to change this into a 2, and that's how you write it. Mg in parentheses HCO3 with a subscript of 2. That's it.